Okay, last time we learned about the concept of work, and by work I mean the concept of work in physics. Today we're going to do a lab to get you thinking about what the concept of work is. To do the lab, you will first need the lab sheets and a partner. This lab cannot be done alone, so you're going to have to get in groups or with a partner. You will need textbooks. I got some nice heavy biology ones here. You're going to need at least 4 of them. You will need spring scales for measuring newtons. These ones actually we have will measure in newtons, so you don't have to do any conversion. Makes the math nice and easy. You will need a meter stick. Remember, work involves something moving a distance. We'll use the meter stick to measure that. And you need objects to lift. On each of your lab desks, you'll find these little weight sets. They're really convenient. They all have the hooks in them. Makes it really easy to work with the springs. So let's look at the first part of your lab sheet. On the first part of your lab sheet, it wants you to stand with your arms waist height. You're going to put one book in each of your hands, lift it to your shoulder level, and then lower them. Then you're going to lift them from waist to over your head. So you're going to put a book in each hand, have your partner put them in, and lift them to your shoulder. Then you're going to bring them down to your waist. Then you're going to take them, lift them over your head. This will be your workout for the day. Then you bring them back down the waist and give them to your partner. And you will go through the questions. These are essay questions, so answer thoughtfully, answer in full sentences, and please use correct grammar. First question will be, when did you do more work? When lifting the books from waist to shoulder, or when lifting the books from waist to over your head? Please explain what you have learned about work. Now flip the page and go to part B. Once again, you are going to stand with your arms out in front of you at waist height. This time you will put 2 books in each hand, and you'll lift them to shoulder length level, and then you will lift them to above your head. See if Mr. Cook can do the balancing act. Ugh. So you're going to start with the 2 books in each hand, raise them shoulder length, waist to shoulder. The next part, you're going to go waist to over your head, and then back down. Preferably you will keep all your books balanced. That's why you want a partner. Then you're going to answer the critical question underneath it, once again in full sentences. Are you using more force when lifting 2 books than when you're holding 1 book? Explain. So you're comparing this to the first part. Now, part C. You're going to start with your hands at your sides, like you're doing a wing. You're going to put 2 books in each hand, and then you're going to move the books up to shoulder level until your arms get tired. In the old days, this used to be a punishment they used to make us do when we'd screw up things in school. So you're going to have them out, you're going to lift them up, and you're going to hold them up till they're tired. Mr. Cook's an old guy out of shape, so I'm not going to hold it up that long. You guys are young, so you better be able to hold it up longer than me. Once you have done that, you're going to answer the following 2 questions. First one, are you exerting a force on the book? Remember back to the definition of what a force is. Question 2, are you doing work in this situation? It is talking about when you have the books out here and you're holding them with your arms spread out. Are you doing work? Once you have answered those questions, you will go to part D. Part D is going to require the spring scale. On your desk, you'll find spring scale of several different colors. Each color represents a different range. So as you get to heavier ones, you are going to want to get one that will cover that range of weights. The blue ones are pretty generic. They will handle most of the lighter weight. The way you will read them is you'll find scales on each side. One side will be a side in grams. And we easily know how to convert grams into newtons. You would convert grams to kilograms, times it by 9.8. Or you can be lazy and there is a side where it is actually scaled in newtons. There is a one-to-one relationship between newtons and mass. The way you read these is on the top, there's like a little plunger. And you have this little screw at the top that you can turn it, and it will move the plunger up or down. You want to hold it so that the hook with no weight on it, no mass, has the spring stretched out. You may want to stretch it out a little bit in case everything's jammed, and then let it hang. You're going to turn this screw so that little flat part is exactly on 0. That is how you calibrate these. Then when you put weights on, it will stretch down and it will go to your number, and you will just read it straight off of here. Look at the scale first so you will understand what each increment. On the small scale, it goes from 0 to 0.5. And there's actually 10 lines in there. So every 2 lines would be 0.1 newtons. So it would go 0.5, 0.1, 1.5, 2, and so on. What you are going to do is you're going to take your meter stick and set it up. I recommend put it so that the lowest number 0 is on the ground and 100 is up there. Remember, 100 centimeters into a meter. You are going to hang a weight onto your spring scale. And you are going to slowly start from the bottom and slowly move it up. And it's going to juggle a little bit, but you're going to have somebody watch. The idea is you don't want a jerky movement where it's bouncing. You want a smooth flow where the newtons kind of stays at one spot. This one is staying at the 2 Newton mark. So if I go from 0 to say 80 centimeters, that means I have moved 2 newtons of mass, 2 newtons for 0.8 meters. Remember to convert the centimeters to meters. And I will use that to fill in the chart. I will fill it out for object, which would be a weight. My force in this case would be 2 newtons. My distance in meters, 80 centimeters, would be 0.8 meters. I would use that to plug into my formula for work. I'm not going to give you the formula. It's on the front of the sheet, and it's something you should remember from last time. You are going to do this for 5 different objects. Getting the object, how much force it takes to lift it, how far you lifted it, and then calculate the work. When you are done with that, you will turn in everything and you will turn in your lab sheet. Please make sure on lab sheets that you put your name and the class period on them so I know whose they are and which class they get in. Failure to do that, we'll get into a deduction of points. So, this will be the work lab. You will now pair up with somebody or get into a team, read through your instructions first, practice everything a few times, and then do it and thoughtfully answer the questions. You may discuss the questions as a group and come up with an answer, but every single person must do their own lab sheet, must do their own answer in their own words. I don't want to see a bunch of answers that are identical word for word. Have fun. Work lab.